Welcome to the 6th tutorial in our scripting series, and we are going to be learning about loops today. I'm going to demonstrate two different things that we're going to set up here, and both of them use loops to do a command that normally you'd need to write it like 5 or 6 times in a row, but if you put it in a loop it saves you time because you can quickly have the computer run through a set of instructions, and instead of typing it out a bunch of times in a row, the computer just repeats it really quickly. So here's what we're going to set up. Here's a treasure chest of some type, and if I walk over here, try to open it, I can't. It's locked, and there's no way to get it. It says a specific key is required to open that object. But one option I do have is I can bash it. I can crack it open by hitting it. Uh-oh. When you do that, you get attacked by skeletons and zombies. Okay, so that's what's happening there is we have a loop that is set up to spawn those two types of creatures, and instead of having to call and create each one of those individually, the computer will create them all at once. Now here's an area where I've got a bunch of these dogs here, and I could try to fight them, or I could destroy this altar and they'll all disappear. And what's happening there is the altar, when it gets destroyed, it looks around to count how many hounds are around, and it destroys them one at a time, and it uses a loop to run through that list. So those are two of the things that we're going to set up, and then there'll be a challenge after that to see if you can take that information and push it one step farther. Alright, so I'm going to take you through setting this up from scratch, and so I'm just going to delete this area. Okay, we're going to go to the area wizard, and we're going to create a new area, and we'll call this one ice. And we'll go and we'll choose frozen wastes. And let's go with 6 by 6. And frozen wastes is kind of like the cave one. You have to kind of paint it out. Most of it's just empty space here. So we go to terrain, and we'll choose floor, and you just can paint out a bunch of space. And if you want to get creative and make it look different, that's okay. I'm just going to do stuff far enough away that we don't run into problems dealing with hounds when we want to deal with the chest. So I'm going to paint my starting area down here in this corner. The ground in this area is kind of like up and down wavy, and so you get kind of spots where it looks like the starting area is disappearing. It's just in a little hill there, but it's fine. Okay, before we get into how to set this up, I want to demonstrate a couple different types of loops that we can use. And to do that, we're going to create an NPC, and we'll go to what haven't we done before? We've done all humans. Let's do a dwarf. These all seem like bad guys. I don't want to get somebody with... well, that's fine. Okay, so we'll get this guy here, whoever he is. This gentleman here. He's got a shield and looks like a skirt. Okay, good. And let's go to properties. Let's just make sure that we set his faction to commoner. That way he'll be friendly. Okay, and so let's go ahead and go to his scripts, and let's delete everything out of here. We'll go back to just using a regular old dummy. And we'll use the on heartbeat. That way, it'll just keep saying whatever we tell it to, so we can keep checking it. But we'll go edit, and we'll save this. We're going to delete this, so maybe we'll start this with DEL dwarf HB. Okay, so we'll do that. And here's what we'll do. Okay, now there's usually 3 types of loops, sometimes 4 depending on the language, but 3 types of loops in most C languages. And there's a while loop, a do while loop, and a for loop. And so I'm just going to quickly demonstrate how those work. They all work on a system of having a counter, and the loop runs until this counter reaches a certain point, and then the loop stops. There's other ways to run the loops, but that's usually how they're used. Here's an example of a while loop, and there's 3 important parts. So the first part is initialize the counter. So I'm going to set up an int called nCounter, and I'm going to start it with a value of 0. Giving it a starting value is called initializing it. So in order for the counter to work right, it's got to start at 0. The second important step is to set up your condition. And for a while loop, it looks like this. While nCounter is less than 10. And then you can do whatever actions you want to. Okay, so right here I'm going to put condition. And so for his, what do we want him to do for the loop? Let's say, okay, and let's change the loop possibilities here to 5. That way it'll have time to run it all through the heartbeat script. Okay, so as long as this loop is, as long as nCounter is less than 5, it's going to continue doing this. Okay, the third part of a loop, and this is super important, is that you have to change the counter. Okay, sometimes that's called the dependent variable, but you got to change it. If it never changes, the loop is an infinite loop. It keeps going forever. So what we need to do is say nCounter equals nCounter plus 1. And so it'll add 1 to itself. And actually, that's kind of the long way to write it. The faster way to write it, nCounter plus plus. Plus plus is a shortcut for saying nCounter equals nCounter plus 1. It just adds 1 to nCounter. Incidentally, you can also do minus minus. If you want to go up by 2, you could say nCounter plus equals 2, or plus equals 7, and it would add 7 to itself each time. You can do minus equals, some number. You can do times equals, and that will multiply itself by 5 each time. So anyway, there's other ways to mess with that, but what we want to do is increase it by 1, and that's called changing the counter. So once again, we have 3 important parts. Part 1 is to initialize the counter. Part 2 is to have the condition run this loop as long as this condition is true. And then 3, you have to make a change to that counter, otherwise the loop will go on forever. If I run this, he should say the word hey, wait half a second, and say hey again. And he should do that process 5 times. Let's see if we can watch that happen. He says, hey, 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 hey. And he said it 5 times. And at the end of the start of the next heartbeat, he'll do it again. 3, 4, 5. Okay? So that's how that works. I'm going to exit that, and we'll talk about our next type of loop. Now, because this procedure is so common in programming, there's so many times where you need to run a loop a set number of times. And you need to have a counter, so you're going to have to do this step. You're going to always have a condition, so you have to do this step. And you're going to change that counter by 1. every single time like that. This happens so often that there is another type of loop that is more efficient in how they lay it out. And so I'm going to write a second loop down here that does the exact same thing, but we'll change the word so you can see that it's a different word. Okay, and this is called a for loop. The previous one is a while loop. This next one is a for loop. So I'm going to say for, and then I have a set of parentheses, and there's 3 slots to fill up in here. The first one is the initialization. So I'm going to say n counter equals 0, semicolon. This is an unusual place where you have a semicolon inside of parentheses. Usually you don't see that. For n counter equals 0, and the second slot is the condition. N counter is less than 5. And then the third one is changing the counter, n counter plus plus. So I'm doing all of the same steps. It's just that they go right up here in the for parenthesis set. 3 slots, the same 3 important pieces, just all in one line. Okay, so really a for loop is no different than a while loop. It's just more efficiently organized. And you can write a while loop to do the task, or you can do a for loop. Either loop can be done. There's just some situations where a for loop usually makes more sense. Okay, what should we do in this one? We'll do a different string. Action speak string. Yo. Action weight 0.5. Actually, we'll do 3 of those. Okay, so n counter starts at 0. It'll keep going until it gets to 3. When it's 3, it'll break the loop and stop. So we should see him say hey 5 times and then yo 3 times. Hey, 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 hey. Yo, yo, yo. Okay. That's the guy. He's working. Okay. Now, there is a third type of loop that's called a do-while loop. And it's very similar to a while loop, except that instead of having while at the top, you have it at the bottom of the loop. And that means that a while loop always will run one time through because it doesn't check its condition until it's done. So I'm going to delete these 2 and write a do while loop here. And then you put a semicolon at the end here. And then whatever you want to goes inside of this. So action speak string. And then of course you have to do your n counter plus plus. So we have the same important parts. It's just that the condition is here. And changing the counter is done here. The condition's at the end. So what that means is, what if I had a false condition here? What if I said, run this loop while counter is greater than 3? Okay. Well, when this script starts, counter is 0. So is counter greater than 3? No, this is a false statement. But what that means is, since it's a do while loop, it's going to run through it one time, then check the counter, and then realize it's false, and then it won't do it. So even though this says 3, it's going to happen just once. And so we'll run this, and because it's on the heartbeat, it'll happen once every 6 seconds, but it will just run the loop one time. So we should see him say hello just once. There it is. Okay, we can delete this guy. Those are the three types of loops: while loop, do while loop, and for loop. And really, a do while loop isn't very commonly used. You probably won't use it ever in Neverwinter Nights, but it is used. It is out there in programming sometimes. And so in this next, what you're going to do next, we're going to set up a while loop and a for loop. We'll do an example of each, and then there'll be a challenge for you to try to do the next part yourself. So let's go ahead and start our next section here. Let's run over here to placeables. Let's go to containers and switches, and let's grab the third chest on the list, and we'll drop that right in front of the player. Right click on your chest, go to properties, and make sure it is usable. We can set the hardness to 1, we can set the hit points to 1. Let's check the locked checkbox, and then let's check the key required to unlock or lock. That way there's no way the player can break into it with lock picks or anything like that. They have to break it open with bash. We'll go to the scripts tab. There's two here, one on death and one on open, and those are just scripts that provide you with kind of the default loot that comes out of a treasure chest, either if you break it or if you open it. We don't need those. Let's choose the on death script, which is what gets called when the treasure chest gets broken and destroyed. We'll click edit, and let's save this as sm_chest_on_death, OD. All right. Now, when the treasure chest gets destroyed, there is a handy function that will tell us who destroyed the chest. Get last killer. Okay, and so get the object that killed the caller. So you can imagine you could put this on an NPC that gets destroyed, and then you could find out which character was responsible for his or her death, and then you could, who knows what, you could come up with all kinds of stuff to do. Kind of a neat method there, function. Okay, let's say we'll create an object. We'll call it OPC, and we'll set it equal to get last killer. And in this tutorial, that definitely will be the player character. We also, remember what we're going to do with this is when the chest gets destroyed, we're going to drop a bunch of zombies and skeletons into the picture. And we have to have a location data type to get that. So we have to know a location for those things to show up. And we're going to use the location of the player character. So let's set up a new location. And our location variable will be called lspawn, because that's where we're going to spawn the creatures. And we will use the get location OPC function. Get location will return the location of any object, and OPC is an object, and that'll give us a location lspawn. Okay, we also are going to need a counter. So we'll just create an int, we'll call it nCounter, and we'll start that with a value of 0. Okay, now remember this gets called as soon as the treasure chest is destroyed, so we're going to start our loop. We're going to use a for loop, and remember we need 3 things here. First of all, we need to initialize our counter, and even though I already said equals 0, whenever you write a loop, it's good practice to reset your counters to 0 in case they've been used before that. Okay. Next is the condition, and we're going to run this loop while nCounter is less than 5. And if it starts at 0, that means it's going to count like this. It's going to go 0, 1, 2, 3, 4. But 0 is one of the trips through the loop, so that's going to be actually 5 creatures or 5 trips through the loop. Next, we have to change the counter, so nCounter++. curly braces, and now we're ready to set up our actions. So we're going to create object, and remember how this function works. We have to give it an object type, which is an int, meaning it's one of these constants here. It's an object type item, object type creature, etc. We will be using object type creature. Then we need a string of the blueprint template for the creature we want to use, and I'll type those in, you'll see what they are. Then we need a location. Our location is already set up, it's lspawn. Finally, we need to know if we want to use the appear animation, true or false. If you say true, for some reason, skeletons and zombies fall from the sky. I think it looks really stupid, so I'm going to say false, and that means they're just going to fade in, which I much prefer. And then again, this is optional. If you wanted to give your new creature, new object, whatever it is, a custom tag when you create them, you could type that in quotations right here. We're going to leave that off. We don't need to reuse these zombies for anything. Okay, so we're going to go object underscore type underscore creature, comma, and then the blueprint for a zombie is NW underscore zombie 01. And again, you can find those by looking through your library and just painting anything you want out in the area, and then just look at its properties and you'll see what the blueprint ID is. Okay, third slot is a location. We're going to use lspawn, which is the player's location. And then finally, we're going to say false for the animation. Okay, the second command is just like this one, so I'm going to copy it and paste it. And the only thing we change is this blueprint here. NW underscore skeleton. And that's it. We'll save it. And let's click OK here. And we can test and see what happens. Okay, if I go to the chest, it is not openable. I can right click it, I can try to unlock it, and it says a specific key is required. Can't do that. So I have to bash it. And as soon as I do, we get all these zombies showing up. And so, you know, the alternative would be to write 5 times create object, object type creature, NW zombie 01 lspawn false, and write that 5 times, and then write the one for the skeleton 5 times. So we'd have 10 lines of code, but instead you write this handy little for loop and you do it in like 3 lines of code and you're done. Okay, all right, let's move on to the next one. And we want to move quite a bit away from this area, so let's go out over here into this corner, and we're going to go to miscellaneous interior, and we'll just pick, let's see, we'll pick this crazy altar, the 4th one down there. We'll put this right there, and oh, it's got kind of a cool glowing something, a skull. Great. Okay. And then we also want to paint some creatures down, some hellhounds here. So we're going to go to, let's see, where are these guys? Monsters. Oh yeah. Planar, I don't know how you say that. Fiendish. And then down to hellhound. And we're going to paint 4 of these guys. And we'll just leave them right there. And then we're going to set up some scripts here. Also, on the altar, make sure it's usable. Altars can be usable just like a treasure chest. That way you could look inside them. I don't know, maybe they got drawers or something you can open. And you might find stuff in there. But for us, that just allows us to bash it and destroy it. Let's, again, make it very weak. Hardness of 1, hit points 1. Make sure we can kill it on the first try there. Doesn't need to be locked or anything. And next we go to scripts. And so we're going to go to the onDeath script. And remember, what we're going to do here is when we destroy the altar, this script is going to look around and get all the hounds it can find and destroy them one at a time in a loop. And we'll do save as, and we'll call this sm_altar_od. Okay, another thing we're going to look at doing in this script is being a little more efficient with the way we write our code. So anytime you have a long string of text that you're going to type over and over again, sometimes you can just put that in a variable name, and it's easier to type it that way. So we'll start off, and also if you name your variables well, it can make it easier to read. So let's do this. Let's create an object called oAltar, and we're going to equal object_self. Okay, now if you think about that, you could just write object self all over the place in here, but it's a little more readable if you say oAltar, because we understand if we pick up the script without recognizing where it's from, we'll understand, oh, this is about the altar and things like that. So this is a good idea. Let's go ahead and add another one. Now we're going to be referring to these hellhounds by their blueprint tag, or by their their tag, which is NW_hellhound. So, but we're going to just put that into a string variable, and then we can just reuse that one. So string, lowercase, string s, we'll call it sHound equals NW_hellhound. That way, instead of typing this, we can just type sHound. We're also going to have an object called oHound, and we're not going to set it equal to anything yet. We need to do that in a minute here. Finally, we're going to have an int. We're going to call it nCount, and we're going to start it out with a value of 1, and that'll make sense here in just a minute. Okay, what do we do with oHound? Well, we need to get the nearest hound that there is. And we're going to use a function called getNearestObjectByTag. Instead of getObjectByTag, because all of these hounds are going to have the same default tag, we want to make sure we get just one of them, and so we'll do this one, getNearestObjectByTag. Okay, and it's going to return us that object, whatever it is. So if this works well, we'll get a hellhound out of this. GetNearestObjectByTag. First, we need to give it a string that has the tag of the object we're looking for. For us, that's going to be sHound. Then we need to give it an object that we are nearest to. Okay? In other words, find the object nearest to something. And for us, we're going to put in the altar. So find the nearest one to the altar. And this one is confusing when you look at it the first time. Int nth equals 1. What that means is get the nth object with this tag. So get the first object, get the second one, get the third one. If you had 25 hellhounds and you wanted to get the last one, you could say get the 25th item with this tag. So what we're going to do is we're going to start out in this loop using nCount for this, which is going to be 1, but the next time through the loop it'll be 2, the third time it'll be 3, and the fourth time it'll be 4. So eventually it'll go through all 4 of the hellhounds that are out there. Okay, we are going to set up, we're going to get the first hellhound in the list. So we're going to say oHound equals getNearestObjectByTag. By the way, if you guys find yourself making a lot of spelling mistakes and that causes a lot of errors for you, if you're about to type in a function, if you have it up here on the list and you double click, I think I mentioned this before, it types it for you. It won't make any spelling mistakes when it does that. So if you're a bad speller, that's a way around it. Better option, improve your spelling. Okay. So our first slot, we need the tag of the object, which is right here, sHound. And again, we could put NW hellhound in quotes, but we can also just put sHound since that's where we saved it. The next one is nearest to what? Alter. And then finally, the nth hellhound you're looking for, which one are you looking for? We're going to use n count for that one. And that's why we started it off at 1, because 0 wouldn't work there. You can't find the 0th hellhound. That doesn't make sense. So we're going to get the first hellhound. Once we have one, we can start our while loop. And we're going to run the loop on this condition. While get is object valid hound. Okay, and I need 2 parentheses there. First set covers hound in there, and the second set matches with the start. Okay, I'm going to hit return. And then we're going to write in our code what to do each time through this loop. First thing we want to do, if there's a valid hellhound, is destroy object. Then we want to increase our counter, n count plus plus. And finally, hound equals, I'm just going to copy this right here. Get nearest object by tag. So we're going to get the next one, because now n count isn't 1 anymore, it's 2, because we just increased it. So we're going to look for the second hound. Once we get to the end here, the loop will start over and we'll check the condition. Is the second hound a valid object? If it is, we'll go in here and we'll destroy it. We'll change this to 3. We'll get the next hound, which will be the third one in the list. We'll go to the top of the loop. Is this third one valid? If it is, we'll destroy it. We'll change this to 4, and then we'll get the fourth hound. We'll go to the top. Is this valid? If it is, we'll destroy it. We'll change this to 5. We'll get the fifth hound. And what will happen here is there is no fifth hound. Okay? And if you look at how the function works, it returns object invalid if there's nothing there. So that means hound is going to be invalid. We're going to go to the top of the loop and it's going to say, is this hound valid? And it's going to be no. It's going to be false. So this loop will stop, and the code will jump down to here, and there's nothing left, so the script will finish, and that's how it works. Now before we test this, I just want to point out, this while loop looks a little different than the one I did before. The one I did before was just counting up numbers. In this case, we're running this loop as long as there are valid hounds to get. So if there was 25 hounds out there, we could keep checking for hounds and keep increasing n count to keep getting the next hound until we ran out. As soon as we run out, hound gets a negative object invalid value, and that will break out of the loop. So this loop is a great loop. It's only going to run as long as there's hounds to be destroyed. Once they're destroyed, we're done. So if you're wondering where the 3 parts of this loop are, well, here's the condition, right? And changing the variable is sort of working indirectly. We're changing n count, but this isn't directly tied to n count. It's just tied to there being more hounds. N count is being used to get the next hound, and so that's kind of where that goes. As far as our initial starting value is, it's this. It's not a number. We're giving it a hound to start with. This loop will run as long as there are hounds, and we give it 1 hound to start with. Now if it turned out that there was no hounds in the area, this loop would check this. It would come up false right away, and the loop would never run. It just would skip. Kind of like an if statement. Okay, they work similarly. All right, save it. Make sure there's no errors. Let's click OK. Save that, and we'll test it out. Okay, now we've got to run quite a ways over here. And there's the hounds. They're coming to get me. And I'm going to go here. I'm going to right click and bash the alter. And all of the hounds got destroyed. Perfect. Okay, now here is your challenge. Here's your challenge for this assignment. I'm going to go over here to where the hellhounds are, and I'm going to start killing them But every time I kill one, the altar spawns a replacement. But it never spawns more than 4. It doesn't just keep on making them. But if I kill a couple... Okay, 1 came that time. And then watch, 2 more will come in a second here. Okay, it'll always spawn up to 4, however many are needed. And if somehow I were able to kill as many of them as I could real quickly here. See how many we get. There's 3, and then 1 more will come on the next heartbeat. So that's what you need to set up. Now, it still works. I can still bash the altar and destroy all of them. So that works. But yeah, the idea is the heartbeat should do a couple things. It should count how many hounds are currently there, and then if that's less than 4, it should create however many it needs to make to get 4 out there. So it's, you know, this is tricky. If you're not used to writing code and solving problems like this will be difficult, but wrestle with it, try to figure it out, and have fun with it.